So this unit that we're starting is how to do antiderivatives when you can't just figure out what the answer is. All the ones that we did so far, like that we did in unit 6, I just said, hey guys, think of a function where this would be the derivative, like just think backwards. All the ones we're going to do in this unit are more complicated. So that's what unit 7 is basically how to do antiderivatives of ones that are more complicated. So what we're going to do today is called U substitution. I didn't even like explain anything yet, so let's turn that attitude around. I don't know who picked the letter U. No one asked me, but it's officially called U substitution. Like if you got out a textbook and went to the index, that's what it's called. Okay. So I know. I don't know who chose that. All right. But U substitution is a way that you do a chain rule in reverse. So remember, chain rule is when you have like a guts of a problem, like an F of G, like you have that inside stuff. That's what you're going to be looking at. So here's the first one that we're going to do. Integral of, actually, I'm not going to read it all to you because you guys can just copy it from me. And with these, you just have to do a lot of them. It's like a practice thing to get used to what do we let U equal. But here's the thing. If you pick the wrong thing, it won't work. And you'll go, oh, I should just pick something else. One year I had somebody say to me, so if we just are willing to not give up and we keep trying, we'll eventually get it to work. And I was like, yeah. If you're not a giver-upper, like these problems will work. They're like puzzle pieces that fit together. If you try enough things, you'll eventually get it to work. All right. But you do want U to be the thing with the highest power. Off to the side here, we're going to write U equals, which is the thing. Then there's only two options here. The thing in the first parentheses or the thing in the second parentheses. Which one has the higher power? 6. Okay. So we're going to let U equal x to the 6 plus 2x squared. So you either want to let U equal the thing with the higher power, or oftentimes it'll be like the guts of the problem, like the insides of it. And again, just through doing practice, you just have to do a bunch of problems to get used to it. Now we're going to do the derivative du dx. You know how we've done dy dx? I'm really glad I gave that as a warm-up. Same thing, it's derivative of U with respect to x. As a heads up, this is the only problem I'm going to write this step out on. After this, we're going to skip it and you'll get used to it. You're not going to want to write it over and over again. But we're going to do the derivative of this. So what is the derivative of? It'll be 6x to the 5th plus 4x. Well, hold on. You're just a little ahead of me. Now, what we're going to do is multiply the dx to the other side. So it's du equals all of that stuff dx. And so what we're going to do is skip this step and jump straight to that one so you don't have to do all the recopying. But for one problem, I just wanted to show you how it got there. Okay. Now, what you want to do and what will happen every time, because you're not going to be given an undoable problem, it will work. Okay. You have to somehow find this in the problem. You can adjust coefficients, but you can't adjust variables. How could we turn this into what's there? Divide by 2. Okay, so we're going to do half du equals, and if you divide these by 2, you'll get 3x to the 5th plus 2x dx. It will work out. That stuff will be there. Miss Cole, what if it's not? You picked the wrong thing for you. And if you are just willing to go back and try again, you will eventually get it to work. It'll work every time. Now, here's where I like to highlight. We are going to substitute, and that's why it's called U substitution, 1/2 du in place of this stuff. So what I like to do is highlight that stuff. 3x to the 5th plus 2x dx. It didn't show up real great on there, but it looks okay. In place of the stuff I highlighted, we're going to put 1/2 du. You get how a substitution works, right? Like we're going to take this highlighted stuff out and put in this.
Oh, got it.
1/2 goes out front, du goes at the end, and whatever you didn't highlight is still there. Whatever you didn't highlight is still there. And I'm going to say that over and over again. So what's still there?
X plus 2x.
But what does that equal?
That equals U.
U.
Oh my.
Here's the point of U substitution. It takes something that looked really complicated and makes it look a whole lot easier, doesn't it? Now, here's the common mistake that always happens, because believe it or not, that usually goes well, because everybody is bright and intelligent and listens to me, and you're all great students, and that part usually goes well. The most commonly missed step is actually doing the antiderivative, which is kind of the most important part. So don't forget to do that. The antiderivative of u, well, how would you do an antiderivative of x? So yeah, good. So it's going to be 1/2 u squared, but there's still that 1/2 out front from that adjustment that we had to do. And what goes at the end?
Now you write constant.
And your last step is to plug back in what u was. Also, we would multiply these together. So that would be 1/4 of whatever squared plus c, and what goes in there? Yeah, this stuff, right? X to the 6th plus 2x squared. If you don't want to write this next part, that's okay. But for one problem, I want you to humor me so that I can show you what it is that we actually did. This is the answer. We're done with that problem. I just want to illustrate something for you. And if you want to write it, cool, your notes belong to you. If you don't, I want you to just watch this, okay? If you have a function that is that, oops, that was squared. Let's make up a number for C. Give me a single digit number. 4. Okay. Say this is your function, and we were going to do a derivative. What rule do you need for this derivative? Chain rule. Okay, humor me. It won't take but a minute. You would bring this 2 down, 2 times a 4th, 1/2. It would drop to a 1. You would keep the guts of it the same, and then you would chain on the derivative of that stuff, which would be, it's plus 4x. This is a constant, so it's gone. And if you took 1/2 of this, what would you get? 1/2, if you distributed it through there.
Oh.
And do you see how that's the original problem? We did it backwards. We did an antiderivative. For what it's worth. I'm trying to get you to actually understand the foundations of what we did instead of just here, follow these steps. But let's try it again.
I like it, I like the algorithm, but I don't like it.
I don't want to actually understand it. Let me just do these problems. See, that's what I was trying to not have happen. Because what does happen with topics like this is people become little correct answer machines churning out correct answers and have no idea what they're actually doing. And that, you know, I try to avoid that. Again, a right answer is a right answer. So at the end of the day, if you're happy with your grade, that's fine. But I want you to actually get what we did. I'm going to let you struggle a little bit. What do you want to try and let u equal?
But this side would be no. X plus 1. Wait, no, it would be.
Say that louder. The stuff, right? It's the stuff that's inside of there. It's the guts of the problem. You want to let u equal the guts of it, or the thing with the highest power. So du equals, and it's du dx, but we're just going to put the dx at the other side. What's the derivative of that stuff? Plus 4 dx. Now you have to find that in the problem, and it'll be there. Otherwise, it's a non-doable problem, all right? We have an x plus 1. How can I turn this into an x plus 1? So what's going to go out front?
1.
Good. 1/4 du equals x plus 1 dx. Here's where I like to highlight. In place of x plus 1 dx, we're going to put 1/4 du. So put 1/4 out front, du at the end. Whatever you didn't highlight is still there. So what's still there?
So it's
E to the u. Now, I said the most commonly missed step is doing the antiderivative. This one's going to look like we skipped it because what's the antiderivative of e to the u? E to the u. So it's 1/4 e to the u plus c. And your last step is to plug this stuff back in for u.
So whatever the unit is gonna be the highest power and stuff.
Yeah, like the stuff, the guts inside. And again, if you pick wrong, it simply won't work. and you'll just pick something else. Like, it will work. It will have to. That's why I really like these problems, because you almost, if you're willing to not be a giver upper, you can't get it wrong. Like, if you're willing to try, like, oh, that didn't work, let me try something else, it will eventually work. So what do you want to try and let u equal? Nope.
No, the X cubed, but.
Good, good. You guys got it. It's the highest power and it's the stuff. It's the guts inside. All right, so what's the derivative of x cubed plus 1?
3x squared.
3x squared dx. Now you got to go search for it. It's there somehow. Times 4. Good. To be really honest, sometimes when there's not an adjustment, like sometimes it's just there and you don't have to do an adjustment, that actually throws people off. They're like, wait, you just don't put a number out front. You could put a 1 if that makes you feel better. All right, if you want to highlight, we are substituting for 12x squared dx. And in its place, we're putting 4 du. Whatever you didn't highlight is still there. So what's still there?
Square root.
Now it is square root of u. How else can we write that?
To the 1 half.
Good, perfect.
Oh.
And the reason you'd want to do that is because we're now going to do an antiderivative. I get why people forget the antiderivative, because you feel like you already worked, right? You feel like, oh, I already worked hard. I don't need to actually do the problem, but like you have to actually do the antiderivative. All right, so good. It would be 2/3 u to the 3/2. You add 1 to the power,
Oh, yeah.
divide by that. So 1/2, if you add 1, it's 1.5 or 3/2, 2/3 out front. Now there's already a 4 there, so bring that with you, plus c. And then your last step is to put this back in. 4 times 2 is 8, so 8/3, that stuff to the 3/2 plus c. All right, I need to write a little bit smaller if I'm gonna make these all fit.
I did not say that. You don't have. Not upset.
So after I teach this, what becomes the problem is understanding when you need u substitution and when you don't. So remember that u substitution is for doing a chain rule backwards. So if you have a guts of the problem, that's when you need a u substitution. Or what I usually say is if it looks more complicated than being able to just write an answer, like if you can't just say what the answer is, you need a u substitution.
So you only use u substitution in chain rule?
Yes, we're doing a chain rule in reverse. It's an antiderivative. So if you have like a function with another function inside of it, like see how this is stuff inside of a square root? That's what I'm talking about. So what would we want to let u equal?
5x.
Yeah, like the stuff, 5x minus 2. So derivative of that is just 5 dx. So there's not a variable at all, which is good because there's not a variable in the problem. If there was like an x here, that would not be a doable problem. Do you see what I'm saying?
Yeah.
Like, because there's not an x here, it has to match. But we do need to adjust for the 5 by doing, yeah, divide by 5. So 1/5 du equals, you can put 1 dx if that, you know what, here, I'll do that. 1 dx, because then when you go to highlight, in place of the 1 dx, you're putting 1/5 du. And I did this one more for us to negotiate the square root than anything else. What's still there that you didn't highlight?
That fraction.
So think about how you'd want to write it. Again, I'm kind of letting you struggle a little bit
Would
here.
that be like a negative 1/2?
Good. It would be u to the negative 1/2. Good. Negative because it's in the denominator, 1/2 because it's a square root. Don't forget to actually do the antiderivative. I know it feels like you already did a problem, right? But you have to actually do the antiderivative. So add 1 to the power, -1/2 plus 1, it's +1/2. That means in front, you're going to put good, a 2. the 1/5 is there, because you had to do that adjustment, and then plus C. And then the last step is you put this stuff back in for you. So how would you put these together? 2/5, 5x minus 2 to the 1/2 plus C. Again, I threw that in there more so that we could like deal with the square root. This next one, as a heads up, is gonna have a little bit of a curveball, but I've seen them like that on, AP problems, so anytime I see a problem like that, I'm like, well, we better do that one in the notes. But if you have good algebra skills, you're gonna be fine. When I get, you would want to just do the x minus 1, but why would you pick the x minus 1 instead of the x plus 3? Because those are kind of your two options. It has the to the 5th power part, okay? So du equals the derivative of that. What's your derivative of x minus 1? Yeah, just 1 dx. So you don't really get to highlight a whole lot in this one. In place of dx, you're putting du. There's not an adjustment number that goes out front. Again, that sometimes throws people off. Like, wait, there's no number there? Yeah, we didn't have to do an adjustment. Now I'm gonna cover this up for just 1 second. When I go to substitute in, this is gonna be what? U to the 5th, that part wasn't too bad. Now over here, I need to substitute in for x. How could I get x by itself in this equation? This is like our algebra skills. Yep, u plus 1 equals x. I just like rearranged that a little bit. And so in place of x, you're gonna put u plus 1. So u plus 1 plus 3 be u plus 4. So we had to do a little bit of rearranging. I told you it was a bit of a curveball. Also, I have to do one more step before I can actually do the antiderivative. You're doing a lot of work before you actually do the antiderivative. What do you have to do with that u to the 5th over there? Yeah, distribute. You're having to do some algebra, okay? What would that give you when you distribute?
6 plus
6. Good, perfect. Now we're gonna do the antiderivative. The antiderivative is almost like the last step at the end. Like you do all this work to make it look nicer and then you do the antiderivative. So what do you think for u to the 6th? 1/7 u to the 7th, good. Yeah, it would be 1/6 u to the 6th, but there's a 4 there. I'll fix that in the next step. Plus c. And then you're gonna put u back in. At this point, I forgot what it was. What is u is x minus 1. So it's 1/7 x minus 1 to the 7th plus, what would this give you? 2/3, good. I wanted to see if you would reduce the fraction. X minus 1 to the 6th plus c. It just involved a little bit of algebra, okay? All right, I got a couple more. Hang in there with me.
Oh.
I have 2 more. You'll be okay.
Yeah. He's got a lot of. Wow. When you came right, that's not.
I know I'm treating you like adults. This is like real college. I think in this unit, there's 4 lessons and I printed the notes on one of them. So 3 of them, you're gonna have to just like have a piece of paper and take notes. That's like
Fun.
like real college.
Oh, yeah.
Because these lessons are very much just like, here, do these problems. Like I don't have a whole lot of like notes, you just do problems. What did I make different about this one? Let's talk about vocabulary. It has boundaries. So what do we call it? Does anyone remember? If not, I'll tell you, or we can play hangman. What kind of integral is it? Oh, there we go. It's a definite integral instead of an indefinite integral. So instead of plus c, this is your fundamental theorem of calculus. Instead of plus c, you will do upper boundary minus lower boundary and get a numeric answer. So your answer should be a number. You get what I'm saying?
Yeah.
Okay. And derivative means slope. Integral means, so that number that you get represents area under the graph. accumulated area. Are you with me?
Yes.
Again, I'm
I
trying really hard to make sure you understand the foundation. Some of you are like, we don't care. I'm like, oh, I'm
I
trying.
understand.
All right, what do you want to let U equal?
Square plus one, square plus one.
And do you see how much better that's getting? Like you can look at it and go, that's the guts of the problem. Like you just have to do a bunch of them. All right, du equals,
Or the,
oh my gosh, why is that so great?
because we have a 4x,
You
right?
don't have to do an adjustment number. You're gonna substitute for 4x dx, but again, that does sometimes throw people off, so be careful with that. Now, don't put the boundaries because we're gonna talk about that. In place of 4x dx, we're putting du. What's still there that you didn't highlight? U squared. You have to adjust the boundaries. It's not hard, but you have to do it. These are x numbers. We're going to change them into u numbers. So all you have to do is take the 0 and the 1, plug them in for x right here, and see what you get for u. All right, so we'll do the 0 first. 0 squared is 0 times 2 is 0 plus 1 is 1. And then if you plug in 1 squared, 1 times 2 is 2, plus 1 is 3. And you will not put this back in at the end. You will skip that step entirely. Okay? So what is our antiderivative for u squared? 1/3 u cubed. Don't put plus c. You will put such that 1 to 3. You will not plug back in. You will just do upper boundary minus lower boundary. So let's see what we get for 3. 3 cubed, 27. 1/3 of that is 9. Minus 1/3. Let's pretend it was multiple choice and you had to keep going. This would be 27/3 minus 1/3. Good, okay, cool. That was not like pulling teeth at all. And again, that is an area under the graph. We're gonna try one more like that just to practice the boundaries. I kind of got close to the bottom of the paper too.
I got it.
You're gonna be okay. Now I put that 8 inside the integral, but what could I also have done? Yeah, and so it's a personal preference. If you want to take that and write it out here, you can totally do that. I mean, it doesn't matter. All right, what are we gonna let u equal? Yeah, and if you said the stuff, great. That's exactly kind of where I want your brain to be, like the stuff, like those things. Derivative of that stuff, 2 dx, but I want it to be an 8. So you're gonna multiply by 4. So in place of 8 dx, we're gonna put 4 du. And then I do put the 4 out front. I like to just sort of evict that from the problem. But in place of 8 dx, we put 4 du. What's still there that I didn't highlight? U cubed. And you have to adjust the boundaries. You're gonna plug them in for x right here. So if you plug in 2 times 2,
2 times 2 is
4 plus 1 is 5. And if you plug in 4, yes, you will get 9. Good job.
Plus 1.
All right, antiderivative for u cubed. Good, it would be 1/4 u to the 4th, but what's out front? A 4th, so it'd actually just be u to the 4th such that 5 to 9, and you're gonna do upper boundary minus lower boundary. I do not know what 9 to the 4th is. I mean, I know it's 9 times 9 times 9 times 9, but whatever that is. And then minus 5 to the 4th. You can just stop there, because without a calculator, that's gonna be a really big number. But do you get that it's a number? It's a value? Okay.